Hello students, in this video I will go through exercise U5A04A where I will be applying the side splitter theorem to the various exercises. And the exercises are taken right out of the Glencoe book from page 489 to 491. Let's take a look. Question 1 reads, if xm is equal to 4, and I'm going to label this here, xn is equal to 6, and nz is equal to 9, we have to find out what xy is. So side splitter theorem says this: I can compare these two sides as a ratio compared to these two sides as a ratio, and those proportions will be equivalent if the two sides are partitioned by a pair of parallel lines, which that is exactly what I have right now. I have mn is parallel to yz. So then I can say, let's say if I call this x here, what will happen is I can say 4 over x will equal to 6 over 9. And I can solve for x, cross multiplying both sides, I end up with 36 is equal to 6x, or x will just simply equal to 6. So x will equal to 6, therefore the full length xy will equal to 10. Now, this is not the only way that you can approach this, okay? Certainly, you can apply concepts of similar triangles, and I guarantee you that you will end up with the same conclusion. So then we can actually say the following. We can say 4, right, xm, so that's 4, over, instead of calling my our x, let's call xy the full length, right? Let's call that full length there. Let's call that y. So the full length, okay, I'm going to call y. And that will equal to 6 over, not 9 this time, because I'm comparing the entire length of that line. So it will be 6 plus 9, which is 15. And if I go about it this way and solve for y, you're going to see that we have 60 is equal to 6y. We end up with y is equal to 10. So we end up in the same exact place. xy is indeed 10. So this ends up being the same exact thing. We can use the side splitter theorem, or we can use the proportional properties of similar triangles, just as we have done in past assignments. Let's take a look at question number 2. I'm not going to go through this long-winded explanation with all the different problems, but I'm just demonstrating that all the theorems before this, they still apply, and they're still applicable. This is just another tool that you have in your toolbox. If xn is equal to 6, xm is equal to 2, xy is equal to 10, so the full length now is 10, find nz. So nz here, which I'm going to call x, and my, that's not directly given to us, but we can certainly solve for it. My is equal to 8. So I can say x over 6 is equal to 9 over 2. See, I'm comparing the partitioned parts, okay? They are going to be equivalent. X over 6 is equal to 9 over 2. Cross multiply, end up with 2x is equal to 54. X will equal to, X will equal to 27. So nz is equal to 27. Is this the only proportion that we could have done? Absolutely not. We could have also done this. We could have also set x over 8 is equal to 6 over 2. You see how the corresponding parts, they still are being compared to one another? And algebraically, we will actually end up in the same exact place. Hold on here. I made a slight mistake. I called this 9 when this really should have been 8. So this should be 2x. So 6 times 8 is not 54, it should be 48. And x, therefore, should not be 27, but instead 24. So therefore, nz is not 27, is actually 24. So my apologies for that. And if we solve it in this way here, you'll see that we actually end up in the same place. 2x is equal to 48. X will equal to 24. It's all the same. Okay. Let's take a look at the next guy here. Triangle ABC. BC is equal to 15. BE is equal to 6. So if BC is 15 and BE is equal to 6, then I know that EC therefore is equal to 9. DC is equal to 12. AD is equal to 8. Determine whether DE is parallel to AB and justify your answer. Well, if the sides are split proportionally, then AB will be parallel to DE. Let's see if that's the case. So I take 6 divided by 9. Is that in fact the same as 8 over 12? So 6 over 9 has a common factor of 3, so that would be 2/3. 8 and 12 has a common factor of 4, and that would be 2 and 3. So yes, they do check out. So AB is in fact parallel to DE. Based on a side splitter theorem. In triangle JKL, JK is equal to 15. JM is equal to 5. So if JK is 15 and JM is 5, then MK must be 10. LK is equal to 13. PK is equal to 9. If LK is 13 and PK is 9, then LP therefore is 4. Determine whether JL is parallel to MP. So if they are indeed parallel, then the following proportion must be true. I can say 4 over 5 will equal to 9 over 10. Is that proportion the same? And here we can see that this is actually not the same, because if we cross multiply this, is 40 equal to 45? That is not the same. So JL is not, JL is not parallel to MP. Would other proportions have held up? That's right. So 4 over 9, is that still going to be the same thing as 5 over 10? That clearly is not. 5 over 10 is 1/2. 1/2 is definitely not the same as 4 over 9. Alright. For 5 and 6, JH is a segment, it is a mid-segment, and KLM, is a mid-segment of KLM. Find X. So JH is a mid-segment, which means this segment here is going to be the same as this segment there. JK is going to be congruent to JL. We need to now find X. If JH is a mid-segment, then therefore all of these parts are going to be proportional to one another. The overall triangle is going to be double that of the small triangle. So therefore X must equal to 10. Again, JH is a mid-segment, so therefore these segments are going to be broken up in that manner. And if you look at this, if we call this Y, this must be Y, then that means the overall must be 2Y. And if this is X, then that means 22 is equal to 2X. Because the small triangle JLH is going to be half the size of KLM, or a dilation of 1/2. Or you can think of KLM as a dilation of 2 of triangle JLH. So therefore X is equal to 11. Find X and Y. I apologize for the grainy appearance, but this is 20 minus 3x, and this guy right here is 3x. This guy, I'm sorry, that's 3y. and this guy is 2x minus 5, and this guy is 1/2 y plus 20. Again, I apologize for the grainy appearance of these images here. So the way in which we compare this, okay, we can say 3y is equivalent to 1/2 y plus 20. And we can say, because these segments here are the same, we can say that 20 minus 3x is equal to 2x minus 5. So nothing is said about these lines here, but anyway, we're just basing it off of this. So if that's the case, then we can combine like terms. We end up with 3y plus minus 1/2 y is equal to 20. What would that be? So that would be 5/2 y is equal to 20. Multiply both sides by 2/5. Y will equal to 8. And over here, I'm going to add 3x to both sides, so I end up with 5x. I'm going to add 5 to both sides, so I end up with 25. Divide by 5, x will equal to 5. Alright, moving on. Side splitter theorem. So I know that that 12 minus 3y over 18 minus 5y is equal to, this is 1/4 x plus 6 over 2x minus 29. I'm also given information that those two segments are going to be the same. So if that's the case, then that means these segments must be the same. So I can say 12y minus, I'm sorry, not 12y. I should say 12 there, not 12y. 12 minus 3y is equal to 18 minus 5y. I'm going to add 5y to both sides, I end up with 2y. I want to subtract 12 from both sides, I end up with 6. Divide by 2, y is equal to 3. These two segments are going to end up being the same because of the side splitter theorem. I can then say 1/4 x minus 6 will equal to 2x minus 29. I will subtract 1/4 x from both sides, and I will end up with 7/4 x. Add 29 to both sides, I end up with 23. I will now multiply both sides by 4/7, and I will have x is equal to 132/7 is x. Okay, moving on. If AB is equal to 6 and AE is equal to 9, find ED. AB is equal to 6, AE is equal to 9. BC is equal to 4. Find ED. So I'm going to call ED x. So I can then conclude that 9 over x is equal to 6 over 4. Cross multiply, I end up with 36 is equal to 6x, or x is equal to 6. So therefore ED is equal to 6. If AB is equal to 12, oh, it's the same diagram. So I'm just going to quickly redraw it. A, B, C, D, E. So if AB is equal to 12, AC is equal to 16, so therefore BC must equal to 4. ED is equal to 5. Find AE. Fair enough. So I'm going to call AE x. So x over 12 will equal to 5 over 4. Multiply both sides by 12, I end up with x is equal to 15. So AE is equal to 15. If AC is equal to 14, same question, same diagram. A, B, C, D, E. If AC is equal to 14, BC is equal to 8, so therefore AB must equal to 6. AD is equal to 21. Find ED. So if ED is x, then AE must be 21 minus x. So I can say x over 21 minus x is equal to 8 over 6. I'm going to cross multiply. I end up with 6x is equal to 8 times 21 minus x. Distribute the 8, I end up with 168 minus 8x is equal to 6x. Add 8x to both sides, I end up with 14x is equal to 168. Divide both sides by 14, I end up with x is equal to, I'm not really sure what that is, so let's see, 168 divided by 14. That's 12. So ED must equal to 12. Alright, same diagram. A, B, C, D, E. So AD is 27, AB is 8, AE is 12. So if AD is 27, ED must equal to 15. Find BC, so I'm going to call that x. So I can say x over 15 is equal to 8 over 12. Cross multiply both sides by 15, I end up with x is equal to 120 over 12. X will equal to 10. Zx is equal to 18. Zx is equal to 18. Oh, and I'm going to apply this for the next couple of problems here. So let me see, w, x, y, z, b. Okay, so let me see here. W, x, y, z, and v. Okay, so zx is equal to 18, zv is equal to 6, so therefore vx must equal to 12. Wx is equal to 24, and yx is equal to 16. So if that's 16, therefore yx must equal to 8. So here for this problem, we need to determine whether Vy is parallel to Zw. So if the proportion holds up, then the two lines will be parallel. Let's see if the proportion holds up. So 12 over 6, is that going to be the same as 8 over 16? 12 over 6 is 2. 8 over 16 is 1/2. They're not the same. So let me just double check to see if I have things labeled correctly, just to make sure. Zx is 18, Zv is 6, so therefore Vx must equal to 12. That is the case. And Wx is 24, Yx is equal to 16. Oh, I got it backwards. So Yx is 16. And Yw should be 8. I got it backwards. My apologies. So therefore this is flipped. So 12 over 6 is to 16 over 8. Is that true? 2 is equal to 2. So yes, Vy is indeed parallel to Zw. It checks out. Okay, we're going to try that again. It never hurts to revisit the problem again, especially when the numbers are so close together, right? Y, V, and X. So Vx is equal to 7.5. Zx is equal to 24. So if Vx is 7.5, Vx must equal to, let's see, what is that? 16.5. Okay. Yw is equal to 27.5. And Wx is equal to 40. So therefore, the other side must be 12.5. Yes. Okay. So we can say 7.5 over 16.5. Is this going to be the same as 12.5 over 27.5? And I don't know, I'm feeling a little lazy just because I look at decimals and I despise decimals. So I'm just going to punch this into the calculator. 7.5 over 16.5. Let's see what that is. 7.5 divided by 16.5. That's, I'm sorry, I wrote multiply. So that's 0.454, okay? And I need to do the same thing again, but this time for 12.5 and 27.5. So they are identical. So because of this, yes, this is going to equal to 0.454, 0.454. So Vy is indeed parallel to Wz or Zw. Let's try that another time. So Z, W, Y, V, and X. ZV is equal to 8. Vx is equal to 2. Yx is equal to 1/2. This should say 1/2. My apologies. 1/2 Wy. So if Wy, let's try to simplify things. Let's call Wyx. So Yx is just 1/2 x. So I can say 1/2 x divided by x. Is this going to be the same thing as 2 over 8? So this becomes 1/2 is equal to 1/4. And this is not the case. Because of this, we can say then Zw is not parallel to Vy. Is not parallel to Vy. Alright, here we go again. So I have Z, W, V, Y, X. Wx is 31, Yx is equal to 21, so therefore Yw is 10. Zx is equal to 4Zy. So, I'm sorry, Zv. So therefore, if I say Zv is x, then Zx is 4x, or this guy is 3x. So I can say 3x over x, is this the same thing as 21 over 10? And we can see that 3 is not the same as 21 over 10. Wx is 31, Yx is good. Right. So therefore we can say that Zw, again, is not, parallel to Vy. Alright, last two. So this is 57 degrees, this is x, so therefore Oh, I didn't even read the instructions yet. JH, JP, and PH are mid-segments. So these are all mid-segments, so therefore these are going to be the same. No. Wait. JH, JP, PH are mid-segments. So, if that's the case, here, before I label this, find the value of x. So what will happen is, here, the point of this problem, because JP, JH, and all these things are mid-segments, then this must be true. So if that's the case, then that means these must be also going to be congruent in that order, in that manner. And these must be congruent. They don't have to be all around the same. So 1, 2, and 3. JP and LM are going to be parallel as a result. So because of that, x will equal to 57 degrees. Okay. Next, same idea. These segments are going to be broken up in this manner because they're all mid-segments. And if that's the case, then we know that if this is 44, then that means this guy here is 44. If this is 76, then that means this guy here is 76. And if that's 76, then that means this is 130. So this is 50 then. So if that is 50, hold on here, not 50, that's 60. That is 60. If that is 60, then that means angle x must also be 60 because these sides are parallel. So x will equal to 60 degrees. Sorry, there's still more. Okay. So we need to find out what x is, I assume. But what are the instructions here? The instructions it's the same instruction that these are all mid-segments, so these are going to be the same, these are going to be the same, and these are going to be the same. So if that's the case, then x will equal to 50 because this longer base is going to be double that of pH. And again, if LM is a longer base, then that means JP is going to be half of that. It is going to be 1.35. So JP is equal to 1.35. Again, because of the fact that we're dealing with mid-segments. Okay, find x and y. So recognizing that those segments are the same, then we can say 2y plus 1 is equal to 5y minus 8. Subtract 2y from both sides, I get 3y. Add 8 to both sides, I get 9. Divide by 3, y is equal to 3. 1/2 x plus 3 is equal to 4x minus 35. Add 35 to both sides, I get 38. Subtract 1/5 x from both sides, I get 3 4/5. Or I end up with 19/5 x. Multiply both sides by 5/19. X will equal to 10? Did I get that right? Yes, because 38 times 5 is 190, and then divide by 19, x will equal to 10. Okay. Again, we're dealing with mid-segments, so therefore these, even though it's not marked, it's not assumed. We know definitively that those segments on the other side must also be congruent. So we can say 1/4 x plus 5 is equal to 1/2 x minus 7. Subtract both sides by 1/2 x, I end up with, or actually subtract both sides by 1/4 x, I end up with 1/4 x. Add 7 to both sides, I end up with 12. X, therefore, will equal to 48. I can also say on the other side, 1/3 y minus 6 is equal to 9 minus 2/3 y. Add 2/3 y to both sides, I end up with y. Add 6 to both sides, I end up with 15. Y is therefore equal to 15. Refer to triangle QRS. Okay, for 33 and 34. So I want to draw another triangle here for 34. So over here for 33, ST is equal to 8, TR is equal to 4, PT is equal to 6. Find QR. So because, again, I'm dealing with proportions here, I can then say 8 over 12 is equal to 6 over x. Right? 8 divided by the entire length, okay, is to 6 over the entire corresponding length. So 8x is equal to 72, or x is equal to 9. Again, I repeat this for the same diagram, QPSTR. So I have SP is equal to 4, PT is equal to 6, QR is equal to 12, SQ, we got to find SQ. So let's call SQ, let's call SQ is equal to x. So I can say x over 4 is equal to 12 over 6. Right? The overall length divided by 4 is to 12 divided by 6. So what will x equal to? Let's cross multiply. 48 divided by 6 is 8. Okay, moving on. CE is equal to t minus 2. EB is t plus 1. CD is 2. And CA is 10. Whoops. If CA is 10, then that means AD is 8. Find T and CE. Okay, so I can say 8 over t plus 1 is equal to 2 over t minus 2. Cross multiply, we end up with 8t minus 16 is equal to 2t plus 2. Subtract 2t, I end up with 6t. Add 16, I end up with 18. Divide by 6, I end up with 3. T is equal to 3. So to find CE, I substitute 3 in. I end up with CE is equal to 1. And moving on, if WX is equal to 7, WY is equal to A, so that's a Y. So WY is equal to A, so this entire length is A. So that means this must be A minus 7. WV is equal to 6, and VZ is equal to A minus 9. So and we need to find out what WY is. So again, because the VX and ZY are parallel, I can then set up a proportion. I can say 6 over 7 is equal to a minus 7, I'm sorry, a minus 9 over a minus 7. Cross multiply, 6 times a minus 7 is equal to 7 times a minus 9. So I end up with 6a minus 42 is equal to 7a minus 63. Add 63 to both sides, I end up with 21 is equal to a, because if I subtract 6a from 7a, I end up with a. So a is equal to 21. So if a is equal to 21 and I need to find out what wy is a, wy is equal to 21. Okay, qr is equal to 2. xw is equal to 12. qw is equal to 15. So therefore qx must be 3 then. st is equal to 5. And we need to find rs and wv. rs and wv. Great. So I can say 3 over 12 is to 2 over x. I'm calling this guy x, and I'm calling this guy y. So I can solve for x. 3x is equal to 24. X will equal to 8. And I can then say 8 over 12 is to 5 over y. Cross multiply. 8y is equal to 60. Divide both sides by 8. I end up with 60 over 8, or what is that? 15 over 2. 60 over 8, or 7.5. 60 over 8 is a 60 over 8. 7.5. Okay. And the last couple of questions here. Okay. If LK is equal to 4, MP is equal to 3, PQ is equal to 6, KJ is equal to 2, RS is equal to 6, LP is equal to 2, find ML, QR, QK, and JH. Okay, so let's start with LM. So to find out what LM is, I then say LM, I'm going to call LMX. And since I know that JL is 4 and JK is 2, then KL is equal to 2. So I can say X over 2 is equal to 3 over 6. So therefore, X will equal to 1. So LM is equal to 1. Let's go down the list. QR. QR, I want to call that Y. So I can say, since I know that 2 over 2 is equal to 6 over Y, Y therefore is equal to 6. Or I can say that QR is equal to 6. QK. QK. Okay, so I can say, I want to call QK Z. Okay, so I can say Z over 2 is to 9 over 3. Why 9? Because I'm comparing QK, which is the base of the larger triangle, to the length of the larger triangle, which is 9 to 3. So Z, therefore, will equal to 6. So therefore QK is 6. And JH. JH. Where's JH? Ah, this guy here. Let's call JH there. Let's call that U. Okay? So I can say U over 6 is equal to 2 over Y, or 2 over 6. So U, therefore, is equal to 2. Or JH is equal to 2. Okay, moving on. AB is equal to x plus 5. AB is equal to x plus 5. BD is equal to 12. AC is equal to 3x plus 1. CF is equal to 15. So I say x plus 5 over 12 is to 3x plus 1 over 15. I cross multiply. I end up with 15x plus 75 is equal to 36x plus 12. Subtract 15x from both sides, I end up with 21x. Subtract 12 from both sides, I end up with 63. Divide both sides by 21, I end up with x is equal to 3. And determine the value of x so that BC, so x will have to equal to 3 in order for these two lines to be parallel. Okay, again, same diagram. AC is equal to 15. So I say 15. BD, AC to CF. So 15 to 3x plus 2 is to AB, which is 12, to BD, 3x minus 2. So that proportion has to be true in order for the two lines to be parallel. So I'm going to cross multiply, I end up with 45x minus 30 is equal to 36x plus 30 plus 24. Subtract both sides by 36, I get 9x. Add 30 both sides, I get 54. Divide by 9, x is equal to 6. That's it.